In 2020, researchers fed hundreds of billions of words into a massive neural network known to the world as GPT-3. Almost overnight, it wrote poetry, summarized complex articles, and generated functional code. The industry looked at that success and drew a straightforward conclusion. To make artificial intelligence smarter, engineers just needed to add exponentially more parameters. But there is a physical limit baked into the silicon itself, known as the memory wall. A GPU's ability to perform calculations operates significantly faster than its ability to pull data from its own memory chips. When models grow to hundreds of billions of parameters, that bandwidth bottleneck forces processors to sit idle, waiting for data to arrive. Because of this, the electricity and hardware costs required to train these massive models climbed into the tens of millions of dollars. If engineers had to keep doubling the size of server farms to get better results, AI was on a trajectory to become a tightly monopolized technology, controlled exclusively by a handful of megacorporations with deep pockets. By 2022, deep learning researchers looked closer at how these systems were actually learning and realized they were building models that were incredibly bloated. Instead of wiring up another 10,000 GPUs to push through the hardware inefficiency, engineers started looking for algorithmic precision. To keep the technology viable, developers stopped trying to outrun the hardware. They began rewriting the core logic of how neural networks process and store information. The foundational architecture required for that restructuring already existed. It's known as the transformer. Older neural networks process text the same way humans read, sequentially, one word at a time. If a sequence of text was too long, the model often forgot the beginning by the time it reached the end. The transformer introduced a mechanism called self-attention. Rather than moving word by word, the network looks at an entire sequence of data simultaneously. It mathematically weighs the contextual importance of every word against every other word in an instant. While this simultaneous processing unlocked a profound grasp of human language, it was so effective that it initially masked the underlying inefficiencies, fueling a deeper addiction to simply scaling up parameter counts. Developers were building massive digital brains, but they were starving them of adequate training data. DeepMind researchers revealed an optimal compute ratio. Every model parameter needs exactly 20 tokens of training data. Their chinchilla model was half the size of its predecessor, Gopher, but trained with 4 times the data, consistently crushing it across all benchmarks. An optimized diet of data produced a smarter model than raw computing power ever could. The correlation between sheer size and intelligence was broken. Even with an optimal parameter-to-data ratio, a base language model is essentially just a text predictor. It has to undergo a secondary phase called instruction tuning to actually learn how to follow commands and format answers. Updating a 70 billion parameter model to learn a new behavior usually requires loading every single weight back into memory, which costs a fortune in GPU time to do repeatedly. Researchers developed a hack called low-rank adaptation, or LoRA. It freezes the massive neural network, inserts a tiny secondary matrix, and only trains that addition. By skipping the frozen weights, developers can bypass the memory wall completely. They can surgically alter a model's behavior using a fraction of the computational power. The simultaneous processing of transformers, the strict data diets of chinchilla, and the lightweight tuning of LoRA systematically defeated the physical compute limits that once held the industry back. We no longer need warehouses full of silicon to make meaningful progress. Highly optimized open-source models, like Llama 3.1, can run effectively on standard commercial hardware. The authority to build AI has decentralized. It has moved out of the secretive megacorporations and directly into the hands of grassroots developers and researchers. Today, an engineer can spin up a localized AWS instance or even use a conventional high-end laptop and train a reasoning-capable language model over a single weekend. Success no longer depends on the size of a server farm. The focus has shifted to the precision of the logic and the quality of the data, putting the true power of AI within everyone's reach.